Hey, I hope you guys are doing pretty good. Miss you guys a lot. The social distancing or social isolation thing is really difficult, but I thought I'll try and create some slides for you guys, help you guys out, make sure you actually understand the material, what is going on. So if you have any questions at the end of this video, at the end of the slides, anything you don't understand, anything you want me to clarify, please don't hesitate to send me an email, and I usually respond quick, and I'll be more than happy to respond to you. Okay, so this slide is going to be based on chapter 13. We did chapter 11, which looked at monopoly, and right now we're just delving into oligopoly and monopolistic competition. Okay, so chapter 13 basically looks at market structures that lie between a monopoly and perfectly competitive market. Okay, and we need to understand how these firms and corporations basically operate, right? So for example, there are three video games sort of companies that actually dominate the market. We have Nintendo, we have Sony, we have Microsoft, and basically those are the only three game companies we tend to have, at least video game console companies we tend to have, and that's an example of an oligopoly. It's neither a monopoly, neither is a perfectly competitive industry, right? So you don't have many firms dominating the market like a perfectly competitive industry, and neither do you have just one firm dominating the market like in the case of a monopoly. Okay, can you think of any other examples of oligopolies, right, in the United States? I'll let you guys think of it, and we'll just move on to the learning objectives. Again, the learning objectives are always crucial. You need to actually understand the learning objectives in order to understand the chapter. Okay, so the first one we'll look at is market structures. Okay, so mainly how firms behave in terms of an oligopoly and monopolistically competitive firm. The second thing we'll look at is basically cartels. They're not the Mexican cartels, okay? Right? We'll look at how firms can coordinate and officially set prices and quantity. An example of a cartel is OPEC. Okay, so that's an example of a good cartel, OPEC. Let me see. Ooh, cool. Can actually do that. Okay. We'll also look at a special type of oligopoly called a Carnot oligopoly. Right, and the Carnot oligopoly involves firms choosing the output levels without pollution. We'll look at the Stackelberg oligopoly, right? And in the Stackelberg oligopoly, there's a leader firm. So there's a leader firm, okay? And this leader firm chooses output level and the other firms react towards it. Then we have the Bertrand oligopoly. So this is supposed to be an I. But thankfully, I have my pen right here. So, hey, can't just make it an I. But you guys get a point, right? We have the Bertrand oligopoly, right? And this is basically involves a few companies deciding at what price to sell. So their main objective is price. Right, and then finally we have monopolistically competitive firms, and this is what the majority of our firms in America or in the United States basically are sort of made from or consist of. Okay, and that is an in-between of a monopoly and perfectly competitive firm, right? So in a monopolistic competitive industry, firms can easily enter the market, but they tend to face a downward sloping demand curve. Okay, so it's sort of a measure between a monopoly, okay, and a perfectly competitive firm. Okay, so let's just go right into it. Okay, so the first thing we'll look at is a couple of the definitions, and we need to define what an oligopoly is. Okay, so an oligopoly, right, is defined as a small group of firms in a market with substantial barriers to entry. Okay, so a small group of firms or producers in a market with substantial barriers to entry. Okay, so an example of an oligopoly is OPEC. Another example is basically the telecommunications industry. Well, telecommunications is really long as well. I didn't know to I just actually spelled it. Okay, so telecommunications industry. So we have AT&T, we have Verizon, we have Sprint, and we have T-Mobile. Essentially, we have only 4 companies, okay? Another sort of oligopoly we have in the United States is the auto industry. Okay, and we have GM, we have Chrysler, we have Chevy, and we have Ford. So essentially, we have only 4 companies, right? So we have an oligopoly in the auto industry, right? So those are examples of oligopolies, and hopefully you guys can also think of other examples of oligopoly, right? And I just forgot, I didn't explain what OPEC means. Well, OPEC is oil producing, oil, petroleum, so oil producing and petroleum. Exporting countries. There you go. Okay, so that's an oligopoly. And then we have a cartel, and a cartel is a group of firms that explicitly agree to coordinate their activities. Okay, so it's a group of firms that explicitly agree to coordinate their activities. Okay, so basically it's an oligopoly that tends to collude together in certain price and output. Okay, so this is an oligopoly that tends to collude together in certain price and output, and cartels tend to be illegal. Okay, cartels are illegal, okay, due to collusion, right? And then finally, we have a monopolistically competitive firm, right? And monopolistic competition is basically any market structure in which firms have market power, but no additional firm can enter the market and just earn positive profit. So there's barrier to entry. Firms have market power. And one thing your textbook actually forgets to mention is that in a monopolistically competitive firm or industry, right, the firm basically faces a downward sloping demand curve. Okay, so the demand curve is downward sloping, okay? But you have so many firms in the market to the point where no additional firm can enter and earn positive profits, okay? Right. So those are a few definitions we need to know, okay? And what actually sort of defines market structures? Market structures differ according to the number of firms in the market. So we sort of know this. The ease with which firms may enter and leave the market, and also the ability of firms in the market to differentiate their products from those of their rivals. Okay, so looking at these 3 things, we have number 1, we have number 2, and we have number 3, right? Looking at these 3 things, we can basically see what a monopoly, oligopoly, perfectly competitive, and monopolistically competitive firm are, and we can basically designate these markets based on these 3 factors. Okay, so I'll just go through. We have a really nice table. I'll just go through the table slowly. Right, these are key properties that you need to know. Okay, so properties of a monopoly, oligopoly, monopolistically competitive firm, and perfect competition. Okay, so when we say competition, we're basically talking about perfectly competitive firms. Alright, so let's look at the first row. Okay, so number of firms for a monopoly tends to be 1. Okay, for an oligopoly, it tends to be few. It could be 2, 3, 4, but it's really few. For a monopolistically competitive firm, it could be few or it could be many. Generally, it tends to be many, but they actually make differentiated products, which we'll actually see later over here. And for a perfectly competitive firm, the number of firms are generally many. Okay, let's look at row number 2. So we have entry conditions, right? With a monopoly, basically there's no entry, right? Hence, you have only 1 company. For oligopoly, there's very, very limited entry. Okay, hence you have a few companies or producers. For a monopolistically competitive firm, it tends to be free entry, hence you have a plethora of companies or producers. And for a perfectly competitive firm, you have free entry as well, hence you have so many identical firms. Okay, due to loss of entry, we have rule number 3, which is looking at the long run profit. Okay, the long run profit for the monopolistically competitive firm or the monopolistic competition and the perfect competition is basically 0, because you actually have so many firms who actually come into the market to the point where it actually drives profits to 0. Okay, we need to look at the long run condition for the perfectly competitive firm, but just know that the long run profit for a perfectly competitive firm and the monopolistically competitive firm tends to be 0, right? Since you have only a few number of firms with a monopoly and oligopoly, their long run profits tend to be positive. What about the ability to set price in row 4? Right? For a monopoly, it tends to be a price setter. Oligopoly tends to be a price setter, meaning they choose their own price. Monopolistic competition tends to be a price setter, right? But in perfect competition, the firms there tend to be price takers. Okay. In terms of the price level, for a monopoly, it tends to be very high. We've already seen that. Oligopoly tends to be high as well. For a monopolistically competitive firm, it tends to be high. And for the perfect competition, it tends to be low. Okay, it tends to be low. Why? Because demand is relatively elastic. Okay, for row 6, strategy dependent on individual rival firms. Well, for monopoly, it's basically easy because it's the only firm in the market, so it has no strategy and it looks at no rivals, right? For the oligopoly, much attention for the oligopoly and monopolistic competitive firms, much attention is paid to what rival firms will do. Okay, so basically what rival firms will actually set their price, or how rival firms actually set their output or quantity, right? And a perfectly competitive firm, no one cares about our rivals. All they care about is the market price. And even if you do care about your rivals, you probably end up with no one buying your good because it's that competitive. Okay, because you have a plethora of firms in there. Okay, in terms of products, with a monopoly, it tends to be a single product. Okay, oligopoly tends to be a single product, but in some cases that product may be differentiated. In a monopolistically competitive firm, usually you have a lot of products, but those products are differentiated. And in a perfectly competitive firm, you have a lot of products, but those products are really identical and undifferentiated. Okay, and row 8 gives you an examples of a monopoly. So you have a local natural gas or utility company. Okay. With the oligopoly, we have automobile manufacturers, like I mentioned. Okay, monopolistic competition, you have books, restaurants. Majority of companies in the United States fall under this market structure, right? And you have the agriculture industry, such as with apple farmers in the perfectly competitive industry. Okay. The next thing we'll look at after understanding market structures and looking at the definition of an oligopoly, cartels, and monopolistic competition is we'll look at cartels. Okay, so cartels, right? So we said cartels are basically oligopolistic firms that tend to have an incentive to actually collude in order to act like a monopoly, so that they can actually set high prices, right, and reduce quantity in order to increase their profits. Okay, so a cartel, right, tends to fall under oligopolistic firms. Okay, they have the incentive to collude and set really high prices. Produce a little, and hence increase their profits. Okay, so a classic example of cartels is essentially the Organization of Petroleum Exporting Countries, which is essentially OPEC. Okay, so organization, I said oil initially. I'm sorry, it's not oil, it's organization of petroleum exporting countries, which is essentially OPEC, right? And OPEC basically acts as a cartel. Okay, OPEC basically acts as a cartel, right? So why do cartels fail? Cartels fail if non-cartel members can't supply consumers with large quantities of goods. Because then the consumers will actually pay for a good from a non-cartel member, and then there's no point in the cartels actually colluding and setting prices really high. Okay. Another reason why cartels fail is that each member of a cartel has an incentive to cheat on the cartel agreement. Okay. Right. So as one is increasing price, the other has an incentive to reduce price and sell more. Okay. So that's one reason, or those are a couple of reasons as to why cartels will tend to fail. Okay. In the United States, cartels are basically illegal due to the Sherman Antitrust Act in 1890 and the Federal Trade Commission Act of 1940. Okay, so basically the Sherman Antitrust Act in 1890 and the Federal Trade Commission Act of 1914 prohibit firms from explicitly agreeing to take actions that tend to reduce competition. Okay, so basically preventing collusion from firms. So preventing collusion from firms. Okay. Another way to actually prevent a cartel is to actually prevent measures. Okay, so measures is another way to sort of get around forming a cartel, right? So by merging a company with another company, you can actually form a monopoly. But governments actually restrict the ability of firms to form a measure, okay, hence actually controlling for the cartels as well. Okay, so in a nutshell, basically that is what a cartel is about. You can read more from the textbook, it has a lot more of information. Okay, but this is just a brief snippet or a snippet of what cartels are basically about and why cartels are illegal and basically how we can actually prevent a cartel. Okay, so remember, cartels are illegal because they act as a monopoly by actually underproducing and charge really high prices. Well, what if oligopolistic firms do not collude? Or what if oligopolistic firms do not collude? Sorry. Okay. What if they do not act as a cartel will act? Okay. How will they behave then? Okay. So there are many models microeconomists have in relation to how oligopolies tend to work. Okay. So to make our lives easier, we'll do the analysis exploring just two firms in the market, right? These two firms will be called a duopoly. Okay, so a duopoly is an oligopoly with just two firms, right? So these two firms will basically act as an oligopoly, right? Just to make our things or our life easier. Okay, and we'll explore three models, right, in which oligopolies tend to behave. Okay, so the first one is going to be called the Carnot model. Okay, and with the Carnot model, firms will simultaneously choose output without any collusion. Okay, then we have the Stackelberg model, and in the Stackelberg model, a leader firm, so you have a leader firm. So one firm tends to be the leader, chooses output, and the other firms actually follow, right? And the third model we'll look at is the Bertrand model, right, where firms do not really care about output, but care about how to set price. Okay, so these are the three models we actually examined, and in this video we're going to look at the Cornell model, and we'll leave the Stackelberg model and Bertrand model for another video. Again, to actually understand these models, we need to hold some key assumptions which are really going to be important. So there are two restrictive assumptions we need to take a look at. Okay, the first one is that all firms are identical in the sense that they have the same cost functions and produce identical undifferentiated products. So undifferentiated means identical and similar products. Okay, so these firms are very identical. They have the same cost functions, right? And they produce identical products as well. Okay, another assumption, and a really simple assumption we hold, right, is that the markets will last for only one period. And each firm will choose its quantity or price only once. Okay, so these are the two assumptions we take a look at in building our model. Okay, so firms are identical in the sense that they have the same cost functions and produce identical and differentiated products, and the market basically lasts for one period. Okay, so to actually understand the equilibrium outcome of a duopoly or a Carnot oligopoly, okay, we need to actually understand how equilibrium works in an oligopoly first and foremost. Okay, so remember that under the Carnot oligopoly, firms will simultaneously choose their outputs without any form of collusion. Okay, and in that sense they can actually arrive at an equilibrium called the Nash equilibrium. Okay, right, we'll talk about a Nash equilibrium later on in game theory, but the concept of Nash equilibrium is applicable here. Okay, so what is a Nash equilibrium in relation to the Carnot oligopoly, where firms choose output simultaneously? Okay, so a Nash equilibrium basically is a set of actions taken by firms, right, such that holding the actions of all other firms constant, no firm can obtain a higher profit by choosing a different action. Okay, a set of actions taken by the firms happens to be a Nash equilibrium if holding the actions of all other firms constant, no firm can obtain a higher profit by choosing a different action. So essentially, firms are playing their best strategy, or they produce in the best possible way they can. And eventually, this definition, I know it sounds really abstract and it sounds nebulous right now, but eventually it will make sense to you. Okay, so now to actually understand it better, let's take a look at an example. Suppose we have only two firms in the market. Okay, so we have two firms in the market, so hence we have a duopoly. And suppose these two firms are actually in the airline industry, so we have American Airlines and United Airlines. So we have American Airlines and United Airlines, and they compete for passengers or customers on flights between Chicago and LA. Okay, each firm must choose its output level before knowing what the other firm will choose. Thus, they choose simultaneously. Okay, the quantity for the airlines is the total number of passengers they choose to carry. Okay, so the quantity for the airlines is the total number of passengers they choose to carry. Suppose American carries QA passengers, so QA passengers, and United carries QU passengers. Right? Then the total number of passengers carried between Chicago and Los Angeles is going to be QA, which is the quantity of passengers carried by American Airlines, and QU, which is the quantity of passengers carried by United Airlines, which equals Q, which is basically the total number of passengers. Okay, so our main question is how many passengers does each airline choose to carry? Okay, so how many passengers is American Airlines going to carry? and how many passengers is United Airlines going to carry. And to find out the optimal amount of passengers American Airlines will carry and United Airlines will carry, we need to find the Carnot or Nash-Carnot equilibrium, okay? So the Carnot equilibrium or the Nash-Carnot equilibrium is a set of quantities sold by firms such that holding the quantities of all other firms constant, no firm can obtain a higher profit by choosing a different quantity. In other words, what is the optimal amount or optimal quantity both firms should choose in order to actually maximize profits? Okay, what is the optimal amount or quantity both firms should choose in order to maximize profits? Okay, and we can actually illustrate this or find the Nash-Carnot equilibrium by using graphical method and using algebra. Okay, so the first thing I'm going to do is use the graphical method, and after that I'll use the algebra. Okay, so with the graphical method, let's look at American Airlines. Okay, so first of all, to actually understand what is going on, let's suppose American Airlines is basically a monopoly. Okay, so we basically at this side of our graph. Okay, let's assume American Airlines is basically acting as a monopoly. Okay, so we're trying to know the strategy each firm will use, right, in choosing its passengers. Okay, but at the end of the day, we need to know that the strategy each firm uses to choose its passengers depends on the demand curve it faces, also the marginal revenue curve it faces, and also the marginal cost curve. Okay, so assuming American Airlines is a monopoly, it won't worry about what United Airlines basically does because it's the only firm in the market. Okay, so if it's a monopoly, let's take a look at panel A. It will produce at a point where MR equals MC right over here. Now let me just call this A. Okay, so at this point, essentially we have quantity being 96, so American Airlines will choose to carry 96 passengers or 96,000 passengers and charge a price of $243. Okay, because it's the point where MR equals MC. That is the point where it's going to produce, so it's 96, and it's going to charge a price in relation to its demand curve, so where it actually touches the demand curve over here, and it's going to be $243. However, American Airlines is not a monopoly. We actually living in a duopoly world right now. Okay, so American Airlines basically shares the market with United Airlines. Okay, so in that sense, American Airlines will actually need to consider what we call the residual demand. Okay, so our good old friend residual demand is coming back again. And remember, the residual demand curve is the demand left to a firm after all other market demand has been met by the other firm. Okay, so residual demand curve or residual demand is the demand left for a firm after all other demand has been met. Okay, so let's assume this is the market demand. Okay, and let's also assume that American Airlines, right, believes that United Airlines will actually fly 64 passengers. Right, so then we know that the quantity for United Airlines is basically QU. Right, so United Airlines is flying 64 passengers. Then the demand curve, which is the market demand curve, will shift to the left by 64, okay, and produce a new demand curve, right, which is going to be the residual demand curve for American Airlines. Okay, so the market demand was a certain number. We don't know the quantity yet. Okay, we know that United Airlines is going to produce 64 out of that number. So the rest of the demand basically goes to American Airlines. Okay, in that sense, American Airlines again is always going to produce at the point where its marginal revenue in relation to its residual demand curve. So the residual marginal revenue equals the marginal cost. Again, at this point right here, where marginal revenue equals marginal cost. Okay. Right. So in that sense, suppose American Airlines decides to produce, and that is what it's going to do. Suppose it decides to produce at the point where marginal cost equals marginal revenue, is going to actually produce 64, or it's going to actually not produce, because it doesn't really produce goods, but you get a point, right? It's going to actually fly 64 passengers, and it's going to charge a price at $211. Okay. Well, one thing you should note is that in a duopoly, the price charged, okay, by each firm is actually lesser than in a monopoly. Okay. And also the total quantity produced in the market. So remember, United Airlines is producing 64. Or United Airlines is actually flying 64 passengers, and American Airlines is flying 64 passengers. So that's a total of 128. Right? So the total passengers which are flying in a duopoly is actually more than in a monopoly. At the same time, the price charge is actually less than in a monopoly. Okay, so a duopoly is, we say it tends to be better off than a monopoly. Right? So this is a graphical representation of the problem. Right? But I understand things look a bit abstract. Okay, so we try and simplify it using algebra. Okay, and hopefully with the algebra you'll understand things better. Okay, so let's assume a market demand function. We're still sticking with the American Airlines example, right? So we have a market demand function given by Q equals 339 minus P, right, where P is the dollar cost of a one-way flight. Okay, Q is the total quantity of the two airlines combined, right, which is measured in thousands of passengers flying one way per quarter, we'll say. Right, suppose each airline has a constant marginal cost. Remember, we said the cost functions in our assumption is basically the same across all firms, right? So each airline has a constant marginal cost, MC, and an average cost, AC, of $147. So we know the marginal cost, right, is $147 for both firms. Okay, again, the question is how many passengers should American Airlines fly? Okay, so AA, which is basically American Airlines, right, how many passengers should it fly? So that is what we're trying to answer given the question. Okay, and to solve this, I'll try and go through it really slow so you guys can actually understand what is going on. The first thing we need to do is find the residual demand curve, or the residual demand equation for American Airlines. Okay, so to actually find the residual demand American Airlines faces, remember the residual demand is basically the demand that American Airlines has left after all the other markets, all the other demand in the market is basically met. Okay, so the demand American Airlines has left after all the other demand in the market is actually met. So we have QA, which is basically the quantity, right, in relation to American Airlines, should equal the market demand, okay, or the market quantity minus the quantity of United. Okay, so that's the residual demand. Okay, the demand or the quantity American is left with after the other market or quantity has been met. Okay, so that is Q, which is the market quantity, minus the quantity from United. Okay, so we have United. Okay, so it's going to be 339 minus P, right? So this is the market function, demand function, which we had, minus QU. Okay, so then we have QA equals 339 minus P minus QU. Once we get that, okay, we should follow step 2, which is rewrite to get the inverse demand function. Okay, so essentially we solve for P. Right, so we have QA equals 339 minus P minus QU. Solving for P gives us P equals 339 minus QA minus QU. Okay, so this is the inverse demand function for American Airlines. Once we get an inverse demand function for American Airlines, we can actually compute the marginal revenue function for American Airlines from this residual demand curve. Okay, so the marginal revenue or the residual marginal revenue for American Airlines, right, is going to be 339 minus 2. So notice there's a 2 here now, times QA. Why is there a 2? Because remember, the marginal revenue is twice the slope. Of the residual demand curve. Okay, so the residual marginal revenue is twice the slope of the residual demand curve, or the marginal revenue itself is twice the slope of the demand curve. So we have a 2 multiplying the quantity in relation to only American Airlines. Note this 2 is multiplying the quantity in relation to American Airlines and not in relation to United Airlines. Why? Because American Airlines cannot influence or determine what United Airlines will produce. Remember, they're producing or actually flying these passengers simultaneously. Okay, so step number 1, we have the residual demand. Step number 2, rewrite to get the inverse demand function. Step number 3, find the marginal revenue function. And once you find the marginal revenue function, it should be simple. From there, you find the profit maximizing output. And this is also going to be known as the best response for the firm. Okay, so we're looking at American Airlines. This is going to be the best response, right, function for American Airlines. Okay, so the best response, the best thing American Airlines can do is maximize its profit. Okay, and this is the output that equates marginal revenue and marginal cost. Okay, so we've been able to find the residual marginal revenue for American Airlines. We have 339 minus 2QA minus QU equals 147. Remember, 147 is basically the marginal cost that American Airlines faces. We can rearrange and basically solve this equation for QA. When we do that, we get QA equals 96 minus 1/2 times QU. Okay, we're going to have QA equals 96 minus half times QU. Make sure you actually understand what is going on. So if you have to pause the video, remember you can easily do so. But try to understand what is going on before you move on. Moving on, since we held the assumption that both firms are identical in the terms of their cost functions, and since both firms are identical in terms of their products they actually end up producing, we will have the same best response function for United Airlines, okay? So for United Airlines, their response function will also look like this. So you have 96 minus half QU, okay? And you can actually use the same steps that we did for American Airlines to find the response function for United, and you should basically get the same answer, okay? So the most important thing to know is that the Conoy equilibrium is the point at which the best response curves basically cross, okay? So then to solve the model, we're going to have QA, right, which is quantity for American Airlines, which is the number of passengers flown, okay, equals 96 minus half times QU. But remember we said QU also equals 96 minus 1 over 2 QA, because it's identical, okay? So from here we can easily solve for QA. From this equation we can easily solve for QA, and in doing so we find that QA equals 64 and QU will equal 64 as well, okay? So once we find this 64, we plug it into the QU function. So it's going to be 96 minus half times 64. Okay, and you should get 64. Okay, and now we can actually find the total market quantity, and it's going to be QA. So that's a quantity from American Airlines, that's a quantity from United Airlines, and that's going to be 64 plus 64, and that's 128, right? And we can also find the price, or the Nash-Conoy equilibrium price, and that's going to be 211. So how do we get to 11? Basically, we go back to our equation. So that was P equals 339 minus QA minus QU. So that's 339 minus 64 minus 64, and you should get 211. So using algebra, we've been able to find the quantity of passengers American Airlines should fly, the quantity of passengers United Airlines should fly, the total quantity that should be flown in the airline industry from Chicago to Los Angeles, and the price that should be set. Remember to go back if you have any questions, and remember to ask me questions if you don't understand anything as well. Let's take a look at another example. Suppose there are two firms. We have firm 1 and firm 2, and firm 1 and firm 2 basically act as a duopoly. So two firms that basically act as an oligopoly. Suppose firm 1 produces Q1 units and firm 2 produces Q2 units. What is going to be the Nash-Conoy equilibrium price and quantity if the market demand function is Q equals 1000 minus 1000 P, and each firm has the same marginal cost of 0.28 per unit? Again, I like learning through steps, so I'll just go through the steps. Step 1 is find the residual demand for firm 1. Okay, how do we do that? It's going to be quantity of firm 1, or quantity produced by firm 1, should equals the total market quantity minus the quantity produced by firm 2. So that is going to be the total market quantity, which you've been given 1000, minus 1000 P, minus the quantity produced by Fem2, which is Q2. Okay, so we have Q1 equals 1000 minus 1000 P minus Q2. Okay, step 2, find the inverse demand function. So essentially you solve for P. So we know that Q1 equals 1000 minus 1000 P minus Q2. So solving for P, we have 1000 P equals 1000 minus Q1 minus Q2. So P should equal 1 minus 0.001 Q1 minus 0.001 Q2. Okay, so we found the inverse demand function. Once you've been able to find your inverse demand function, you should be able to find your marginal revenue for Fem1. So remember, we're looking at things in relation to Fem1. Okay, so the marginal revenue for Fem1 is going to be twice the slope for Fem1. So that is going to be 0.001 times 2 for Q1. Because remember, Fem1 has only influence over Q1, but has no influence over Q2. So we just have to be concerned about Q1. Okay, so it's going to be MR equals 1 minus 0.002 Q1 minus 0.001 Q2. Okay, how did we get this 0.002? We just took this and multiplied it by 2. Okay, so essentially that is step 3. Step 4, we find the best response function for Fem1, and to do that we have MR equals MC. So we have 1 minus 0.002 Q1 minus 0.001 Q2 should equal the MC, which we said was 28 cents or 0.28. From here we can easily solve for Q1, and we find that Q1 is 360 minus 0.5 Q2. Remember the assumption we held, the firms are basically identical in terms of their cost functions and also the products they produce. So Fem2 will also have the same best response function as Fem1. Okay, so then we have Q2 equaling 360 minus 0.5 Q1 as equation 2. Okay, so all we did is just substitute Q1 over here, we had Q2. Okay, now since we have Q2, we can plug equation 2 into equation 1. Okay, so then we have 360 minus 0.5 times 260 minus 0.5 times Q1 equals Q1. From here, we can solve for Q1, and solving for Q1 should give you 240. Okay, and thus Q2 also equals 240. Okay, from here you can easily solve for your P, and P in this case is going to be 1 minus 0.001 times 240 minus 0.001 times 240, right? How do we get P? Remember P from our initial equation, okay? And you should get P as being 0.52 or basically 52 cents. In this case, we didn't look for the market quantity, but the market quantity is going to be Q equals Q1 plus Q2, and in that case it's going to be 240 plus 240, and that should equal 480. Again, if you have questions, please don't hesitate to ask me. This is my first time, or this is basically the second time I'm actually doing voiceovers. So I don't know how I sound. I don't know how I will sound eventually. Eventually I'll know how I'll sound, but I just want to make sure that I'm clear enough. It's just weird just doing this without actually seeing people's reactions and seeing people look at you or like see people ask questions. So just let me know if you have any questions, okay? Okay, so let's do practice. Okay, so I want you guys to try this on your own. right? So in a Conour duopoly, each firm has marginal cost MC equals 20, and market demand is Q equals 100 minus 1 over 2P. What are the best response functions of each firm? So that's what I want you to find. The first thing is find the best response functions of each firm. And what is the best output level for each firm? Okay, so take a moment, just pause the video and just work through this. Eventually, you should get these as your answers. Q1 equals Q2, which equals 30. Okay, so if you actually had 30, it means you're doing it right. Right, the next thing we'll do is we'll try and look at the relationship, okay, between the profit maximizing condition and elasticity. Okay, so we can also write a typical Conour firm's profit maximizing condition as MR, which is basically the marginal revenue for the Conour firm, equals price, which is set in the market, times 1 plus 1 divided by N, where N is the number of firms in the market, so number of firms in the market times epsilon, which is basically the market elasticity, should all equal MC. Okay, so in a way, we link in MR to the number of firms in the market, we're linking it to the elasticity, and we're also linking it to price. Okay, just as we did in chapter 11. Okay, so from that equation, if N equals 1, the Conour firm is basically a monopoly and faces the same profit maximizing condition we had in chapter 11. Okay, so we have MR equals P times 1 plus 1 over epsilon. Okay, and this is the same profit maximizing condition we had in chapter 11 in relation to elasticity. All right, and chapter 11 was talking about monopolies, right? So if N equals 1, the Conour firm is basically a monopoly, which actually makes sense. If N equals 1, it means there's only one firm in the market, and hence you tend to have a monopoly. Okay, the more firms there are, the larger the residual demand elasticity, which happens to be N times epsilon a single firm faces. So as N grows very large, the residual demand approaches negative infinity. Okay, as N grows to infinity, the residual demand approaches negative infinity, and the equation becomes P equals MC, which essentially is the profit maximizing condition of a price-taking competitive firm, as we saw in chapter 11. At this point, if you're confused, I would suggest you should go back to chapter 11 to take a look at it. Okay, which actually makes sense as well. As there are more firms in the market, the market becomes more competitive in nature. We can also find the Lerner index for a Conour firm. Remember, the Lerner index measures the market power of the firm, 0 being no market power, like in a perfectly competitive firm. So 0, no market power. And then we have 1, equaling absolute market power. Essentially a monopoly. Right, so Cornell's firm's Lerner index depends on the elasticity the firm faces. Okay, so we have P minus MC divided by P should equal -1 over N. So this time we have N over here. Okay, so N is supposed to be the number of firms. Right, so if N equals 1, right, the Cornell firm's Lerner index equals the monopoly level, right, which we have -1 over epsilon. Okay, so back again to chapter 11. So just in case you're confused about this, just take a look at chapter 11, okay, and it should be helpful. Okay, so then we have P minus MC over P, which equals -1 over epsilon. Okay, and that is the Lerner index for the monopoly. Also is the Lerner index for the Cornell firm if there's only one firm in the market. Okay, finally we have non-identical firms. Okay, so we assume that in our Cornell example the firms had identical costs and products. Okay, well, in the real world, this is not always the case. Okay, so what if the firms are basically non-identical, right? If the firm's marginal costs vary, then the firm's best response functions will vary as well. And in the Nash-Cornell equilibrium, this is something you should take note of very, very well. The relatively low cost firm, in terms of marginal cost, will tend to produce more. Okay. Also, as long as the products are undifferentiated, they'll both charge the same price. Okay, but the relatively cost firm will actually tend to produce more eventually. Okay, I want you guys to take a look at this problem. And solution to this problem is given on page 445. And I want you guys to work through this. Okay, so page 445. Try and work through this problem. Okay, so this is a Cornell duopoly where you don't have identical firms, where basically the firms are non-identical. Okay, solution to this problem involves first determine the marginal revenue for linear demand functions. By calculating each firm's marginal revenue function. Okay, after that, you equate the marginal revenue functions, the marginal cost, which is similar for both firms, I think, in this example. Yes, similar for both firms. Okay, and then find the Nash-Cornell equilibrium by using the best response functions. Again, visit page 445, work through it, and please make sure you understand it. But if you don't, please don't hesitate to send me an email. Okay? That'll be today's lesson. Next time we'll look at Stackelberg oligopoly and Bertrand's oligopoly, and we'll look at monopolistically competitive firm. Okay? See you guys.